Hey everyone, this is Peter. Today we're going to be talking about chirality and chirality centers and specifically finding them, and then also we're going to be doing some looking at some symmetry. And then along with symmetry, we will be going over some fish projections and RS configurations. Starting off with our chirality and finding chirality centers. You have to note that chirality, I'm going to spell this out, equals a molecule, right, carbon, that has four different types of bonds, right? So each letter here represents a different type of bond, and why that's important is because in molecules we can't have when a carbon has two bonds of the same type, that would not be a chirality center. So I'm just gonna show you a few other examples of what this looks like. So we have X right here. That's also a chirality center. Again, note that it means they're different for different molecules or different atoms on the end. Alright, those equal the same thing. So what I'd like to show you right now is 2-butanol and 2-propanol. Alright, here we have the 2-butanol. The reason we know that it's chiral, alright, you can take a moment to pause if you want to try it yourself, but because we have right here one group, alright, a different group, another group, and this hydrogen by itself is a group. Each of these groups is unique, alright. I'm going to show you just now 2-propanol, and there we'll find our next term is achiral, right? As you can see, we have two methyl groups. Same thing. That means when we have two methyl groups, that now this this molecule is now achiral. Alright. There's two of the same group. That's achiral, right? Alright. Now, let's do some examples here to help you out. Alright, here we got 2-bromopentane. Alright, here on top. Now we're going to look to see if we can find some chirality centers. That's what we're going to look for, alright? 2-bromopentane, alright? First glance, we see right here, alright? That would be, it has to be four different bonds, alright? And then this carbon, in this structure, there's also, you gotta remember, you have a little hydrogen over here on each carbon. So even this one right here, hydrogen. We can't forget those. Those are very important because those also contribute to groups. Alright, right here. So we got one group, another group that comes off, this group, and then finally that hydrogen group. Alright, that's 4, alright? That is a chirality center because there are 4 different groups. Next, let's look at 3-bromopentane. Alright. Now think a moment, would this be a chirality center? Or is it going to be achiral? Well, if we look here, alright, let's remember about the hydrogen. Okay. You have two separate, we have a carbon group right here, another carbon group right here. Now when we have two carbon groups, or any molecule that have the same exact both sides, we go to the second group, okay? The second. Looks like we got another carbon, and we got another carbon here. And that's where it ends, alright? So we know, if we look back, achiral is two of the same group. Here, we have two of the same group. Right here, one right here, one right here. Without even looking at the bromine and hydrogen, we know that this cannot be a chiral center. Seeing that it is a carbon with 4 different groups. Now we know that we have achiral. It's achiral because 2 of the groups are the same. So this structure, 2-propanol, is achiral. Alright, let's look at another example. We got 1-bromo-2-methylbutane. Okay. And just for some nomenclature practice, I'm going to write that out. Note that we put the alphabetical B comes before the M here. Right? That's why the bromine gets priority. Okay. We have now here. Do we have a chirality center? Let's take a look. All right. Don't forget about this. Hydrogen. Okay. One group. One group. One group. Group. All right. If we look here, this is very similar to our previous group. But look at this. This bromine group. This bromine. All right. Let me reverse it a second. We have identified 4 groups. This, so we go to carbon, okay, carbon. Both reach carbon on both sides, okay. We have a second carbon here, but on this side is a bromine. So these two are different. And here is a single methyl group and hydrogen. So this is a chiral center right here. 4 different sides, okay. 4 different groups. Okay, so this is chiral. All right. Let's try one more example. I have 2-bromo-2-methylbutane, right? Br. Alright, how about this one? Alright, the only possible chirality center is going to be right here, okay? Because that's the only one with 4 different substituents or different groups coming off of it, so to speak. It can't be. The reason it's not this carbon or that carbon is because we only have one group going that way, one group going that way, and then you can't have 2 of the same hydrogens, obviously. Okay. That would not be a chirality center. Okay, so then we got our bromine here. Alright, so this is achiral, and the reason it's achiral is because we got these 2 methyl groups right here. Those are the same exact groups. That's why it cannot be. We cannot have a chirality center. Or we cannot, yeah, that's why it cannot be chiral. So this one, achiral. Alright. Alright, let's look at these 2 structures. Let's identify the chirality centers, if any. The first one's going to be 2-cyclopentanol, and then our second one we have here is 3-cyclopentanol. Very similar structures, we just have the double bond in different spots. Okay. Now, let's take a look at this. Our only possible chiral centers in this structure on the left is right there. That's the only possible structure. Now, this is very common that in these cyclo groups, when we get these rings, that people forget about these hydrogens. It's important to remember that hydrogen because it counts as a group, and it's very important later in this chapter when we get to having to get RNS configurations. Alright, so we got that hydrogen group is one group, alright? We have this OH group, our alcohol group. Now, just like we did before, we're going to follow We have two carbons that go on each side, so we're going to follow, okay? This side, carbon, carbon. All right. This side, carbon, double bond to carbon. All right. So we have double bonded carbon, which essentially means two carbons at the same time. So this right here is different, which means that this is a chirality center. So yes, chirality. Chiral. How about this structure? The next structure, 3-cyclopentanol. We're gonna do the same thing. We're gonna go OH, okay? We're gonna follow 1 carbon, 2, still another carbon, okay? This side, 1 carbon, 2 carbon. Now look at this. No matter which way we go, we're gonna run to that double bond. It's gonna be the same thing. So what does that mean? This structure and that structure are the same structure. That means it cannot be chiral. It is achiral. Alright, this is chiral. A chiral and achiral are the opposites. So just if you remember one, you'll have the other one down. Our next big topic is symmetry and achiral structures. One of the easiest ways to find if something's achiral is if it has a plane of symmetry. Let's take a look at some few simple problems. All right. So this line, these two lines are just true. That's going up, and then that back line is going to be down. And off this top, we have a CH3, which is a methyl group. All right. And then sweet A. Well, let's think about this. Does this structure have a plane of symmetry? I'm going to switch colors here. Okay. Now look at this. This group, you go like this. Think of this structure. We can look at this 3D. This is our plane of symmetry. It's coming down. And remember this carbon? That carbon, hydrogen over here, hydrogen over here, hydrogen over there. Alright. There's a plane of symmetry that splits these two, so it is achiral. Let's look at another one. Bear with me with this drawing. Do we have a plane of symmetry here? Notice the methyl group comes out on the lower right side. Alright. As you notice, we can't draw a plane of symmetry here. Okay. Do it this way. It's not the same. Can't go diagonal. So here, this is not plane of symmetry. No symmetry.